Okay. Yeah, I will. So I'm recording this locally to my computer. After this, I will upload it to YouTube. I don't know. I'll share the link on Blackboard with everybody afterwards. So on my screen, there are two relations. One called enrolled on the left, another called students on the right. A relation is comprised of a schema and an instance, and a collection of relations together are called a relational database. Now, for a relation must have a key. A key is something that is an attribute or collection of attributes that uniquely define any row in the table. I will also use the word vector or entry and to mean a row like this. Just if you get confused about me going back and forth with vocabulary, just say something. So for the students relation, what would you suggest as being a good candidate for a key? And you can just type your answers. I'll read them. SID, great. What if I wanted to choose name as a key? Would name also work as a key? If yes, why yes? If not, why not? Okay, yes. So Danielle says because it's not unique. In this case, the name is unique, but I see some other answers that add some qualifiers that are a little bit better. Names don't necessarily have to be unique. They may not be unique, even though in this case they are. There might be two Johns, as Danielle says. Right. Okay. So how about for the table enrolled? What would be some good A key or some candidate keys that would be appropriate for this? Okay, I'm seeing lots of answers. We'll have to start agreeing on some notation. For example, if I'm seeing SID and CID, but sometimes people are writing it this way: SID, CID, or SID plus CID. There's some other variations that I'm seeing without the parentheses, SID, CID. Now, each of these can be attributes that can define a key, and there is a difference between, for example, if I wanted to make, I'll give two options. I'll say one, SID, CID, I'll say this, SID primary key, CID unique key, or otherwise SID, CID, and I'll write it here with parentheses as a, I like the word concatenated key. That's more clear to me, but you'll also see this as a candidate. I'm sorry, not as a candidate key, a composite key. SID plus CID, since it allows a student to be enrolled in multiple courses. Yes, this is true. So of these, the second way is the right way to do this, and I will sort of write, I don't know, a line connecting these in this way to show that these are concatenated keys. The difference is if you don't have this, in the student ID column here, there's no issues. Each of these rows are unique according to that key. But in the CID, there would be some rows that would be problematic. For example, the second and the third row. These conflict with each other if we were doing it in this first way. This entry wouldn't be allowed, nor would this entry and this last entry, because they conflict with other rows. But if you instead make these a concatenated key, then it's the pair 1111 lit 101, both of those glued together. And so now 222 and music 101 is different than 333. I'm sorry. This music 101 is okay. Yeah. But this 333 math 101 and 4445 math 101, these are now, this is okay. There's no conflict between these two, where if you are just using it as a primary and a unique key, then these two rows interfere with each other. Okay, so that's just a quick review of a candidate key, or of having, in this case, we have two candidate keys, SID and CID, where the best primary key for this table is the combination. So here, this entire key would be a primary key. In this case, there is no unique key. All right. Now, if we wanted to have these two relations exist together as a database, so I'm not considering the enrolled, I'm not considering each of these tables independently of each other. Instead, I am considering each of these together inside of a single database. Then you can have keys. Actually, let me keep that there just because. Right now, the SID attribute, this row or this column in enrolled, and this SID in row or for relation students are independent of each other. Let me stick with the same colors here. That is to say that, for example, this SID 4445 does not exist in this SID table. It could be the case that when you're designing a database that's allowed. Maybe these are just two independent student IDs, but it could also be the case that you want the students from this relation to be enrolled in these courses, and no other students can be. In this case, you can make SID a foreign key that points to students. So here, SID is now a foreign key. There's a couple things about a foreign key. But doing this, well, it has a couple of consequences. First of all, there are entries in the enrolled table which are now not allowed. In particular, there's these two rows, because this 4445 doesn't exist in the student relation here. So this row would not be allowed. If you tried to insert this row, 4445 Math 101A, into the enrolled table, you would get an error, because the SID that defines this entry doesn't exist in the student's relation. A similar thing happens with 4446. So both of these are not allowed now if I define SID to be a foreign key. I have let's see, I'm seeing. So PK with UK, the uniqueness is checked separately, whereas concatenated keys uniqueness is checked jointly. So in a primary key with unique key, the uniqueness is checked separately. Correct. If I have this SID as a, for example, primary key and CID as a unique key, then independently you check these rows as being unique, and or these columns in these rows as being unique, as well as these columns in these rows. They're checked separately. Concatenated keys you check jointly. Okay. So if I define SID in enrolled to be a foreign key pointing to the SID in the student's relation, there's two rows in the enrolled relation that wouldn't be allowed. How about this one in the students? So 5555 appears in the student table. It does not appear in the enrolled table. So is this entry allowed or not? And I'm just sort of polling the class. So you can say, I don't know, allowed or not allowed for what you think. If is this allowed or not? Correct. Yeah, so this is allowed. The restriction isn't here when I'm writing a foreign key in this way. The restriction isn't on where the head of this arrow is. The restriction is on the tail of the arrow. So foreign keys allow, with things set up in this way, students can be allowed to not be enrolled in any courses. And that's basically all there is to say about a foreign key. There is one last thing, which is that if something is a foreign key, you can also use the null value. This is okay. for foreign keys. This is not okay for primary keys. So I couldn't have an extra row here with a null. This is not allowed because SID in the students table is a primary key, but in the SID could be null as a foreign key. This is also the case if you made this, if this was a primary key and this was a unique key, then nulls would not be allowed for the primary key, but nulls are allowed for unique keys. So that's another differentiating factor between primary keys and unique keys. Those are just sort of some edge cases. Okay. Is SID the foreign key of enrolled, or is SID the foreign key of students? So it depends on which relation you're speaking about. As defined, let me get rid of this. As defined in this way, SID enrolled. This is the foreign key. So SID is a foreign key for the student SID. Here, this is a primary key, and this is called the foreign key. Okay. All right. So now I have a question. Let's say this entry in the students table. So everything is defined just like this. The enrolled has SID, CID as its primary key, the concatenation of them, with SID being a foreign key and this being a primary key. What would happen if I wanted to delete this row? Is that something that's allowed? Has primary key SID. The students table has as a primary key the SID. SID is a foreign key for the enrolled relation. Okay, so I'm seeing some answers. Yes, by default, the default is that if you wanted to delete this row in this relation, you would be disallowed from doing this because this foreign key exists, or this key exists as a foreign key in a relation, so it's being pointed to by another relation. If you wanted to delete this row with 555, that is okay. So you could delete this because 5555 doesn't appear in the enrolled relation. But 4444 would be, you would be prevented from doing that. You can't have... Right. So the default behavior, let me write this out. to save some time. Oh, shoot. Okay. By the way, I'm fine with you drawing out tables or writing it like in this way. I sort of prefer this way personally, but you can do you can write a relation in this way as well. Just be clear about the if things are a concatenated key or not. I'm doing that by just drawing a connecting line between the two. So here, the primary key is specified in this way, and there is no unique value. Furthermore, there is a foreign Okay. So this is the way to specify how this relation is defined now with these underlined keys, and this arrow is a foreign key. There's the SID, the course name, the CID, the grade, and the primary key. There's only one primary key. It is a concatenation of student ID and class ID. And in addition to that, the SID is a foreign key that references the student's relation. Now, just a quick note. If you wanted to rename this, for example, I don't know, student ID. So this attribute, now I'm calling it something different than the thing that it points to. The way that you would make sure that it's pointing to the SID in the student's relation is you just add the SID here. If the two keys happen to have the same name, you can omit it. Right. So if you deleted 444 in enrolled, would you lose their grade for Math 102? You mean if I, let's see, who's asking this? Dan, is your question if I deleted this row in enrolled, or if I deleted this row in the student relation? The one in enrolled. So by default, sure, if you wanted to delete this row, no problem. Yeah, doesn't violate anything. I mean, you'd of course lose all of this information, so yes, you would lose the grade and everything else. But you can delete this entry. If this entry exists in enrolled and you wanted to delete this entry in students, that would not be allowed. You would get an error by default. Okay. Now, there are other options. There's 4 different options. what I just said is the default one. That if you have a foreign key like this, you would, and you tried to delete this row, you would just get an error from the database saying that that's not allowed. If you deleted this row first, then it's okay. But with the existence of a row in enrolled that is using the same key, you would get an error. But there's three other options besides that. Enrolled SID is the foreign key to student's ID. Correct. Enrolled SID is a foreign key to the student's SID. That's right, Toyin. Another option that you can specify is if you delete this row, then everything else that points to it also gets deleted. This is called a cascade. Okay, so one, the default is it's called no action. So that means that no action will happen. If you try to delete this row, nothing will happen. You'll get an error. That's the default. The second option is cascade, which is if you delete this row, then it deletes the corresponding row of anything that that points to it. The third option is replace with null, which if you delete this row, then that is allowed, but then this will just take on the value null in the enrolled table. And the fourth is replace with a default value. So here, instead of replacing this with null, maybe I have defined a default value of all zeros, for example. So here is the way to specify that. Oh, and so this can happen for deletes and updates. An update is just if you're changing a row, not deleting it. So no action just means that you're not allowed to delete it in the first place. Cascade deletes all tuples referring to the deleted one. Set null and set default just change the foreign key value to either null or default. You can specify different actions for each delete and update. So in this case, this is the same as above, except now I'm changing the default to say if you delete a row in the students table, then to delete the corresponding row in the enrolled table. And if you change the student ID in the student table, then change the corresponding SID in the enrolled table to some default value. What does set default mean again? Right. Oh, I'm sorry. Here, on update set default, this means no action. No, I'm sorry, set default. This means that that there would be some default value that you would have. So, for example, default all zeros. So what that would do is if I were to, here in the students table, now I'm not deleting this, but maybe I'll update this to 6666. In this case, take the corresponding entry in the enrolled table and replace it with the default value of all zeros. What's the default delete and update if you don't specify? The default is no action. That means that you're just not allowed to change the student table. Right. So here, on update, if I had this on update default, that would be the same as just not having this at all. So there is no difference between this and this on update default. So you can specify it if you want to be explicit, but you don't have to set it. So the no action, this is the default. Okay, that is it for foreign keys. Any questions before we move on? I'll take the silence as a no, but again, I prefer people actually writing no. It just feels weird. A little bit. Yeah, thank you. Okay, so now we're going to focus on how to go from an ER diagram to develop a relational model. So this is the simplest case. When you have an entity, so an entity it has a name, it has some number of attributes, and at least one of these attributes here, the social security number, is a primary key. It's a very easy transition. You create a relation that will have the name here, employees. That's the name of the relation. And the 3 attributes become 3 columns. And I'm specifying, in addition to the names, the types. So here, social security number is an int, the name is a string, the lot is a string. When I'm writing string, this is just sort of shorthand. Really, you have to specify it as being a character array. So this is another way to write it. So there's 3 named attributes, each with a different type. Maybe I'll make this a string as well. This is to account for the dashes, basically. So social security numbers have 9 digits, but 2 dashes, so whatever. And that's it. So for entities, it's very straightforward, very simple thing to do. Now, here I have a slightly more complicated entity relationship diagram. And so here we have 2 relations. One is employee, 2 entities, the employee entity and the department entity. And they are connected with this works in relationship. Let me go ahead and make this unique. So here I've sort of written this in a set form, giving an example of you would have some number of employees. This is a set of employees. You would also have a set of departments. And the works in relationship is the way that these two, that elements between the 2 sets are related to one another. And here we have, copy this. So we have the employees relation. I will write the department relation. I'll keep it with the char 11. I won't change things too much. Dname, and it has a budget. I'll make this an integer. Okay, and the primary key here is DID. So for each of the relations, for each of the entities, it's a very straightforward thing to turn these into relations. So this entity becomes a relation in this way, and this department entity becomes a relation in this way. Now, what's missing is how to capture the relationship. And I'll also write this as a table. I don't know which way you guys prefer. Give a little bit more space here. So this would have DID as a primary key, dname, budget, int, string. I'll omit the types just to save some time. Okay, so can I hear some suggestions? How do you think that how to capture this relationship aspect here? How should I capture that in this relation here? Okay, Alina says a third table. Are there any other thoughts? Let me make a third table. I'll call it works in, I guess. And a composite key, SSN DID, to the third table. Put the primary key of DID in employee table. Okay, any other ideas? I'll get to more of them, but yeah, I'd like to see some more responses if possible. Employees can only belong in one department. These are thin lines here. So this is a thin line for employee and a thin line for department. So those are unconstrained. There is, so an employee can belong to no departments. An employee can work in many departments. A department can have no employees. It can have many employees. Everything is okay. Can I repeat the question? My question is, we're focusing on how to take a relational model, an ER diagram like this on the left, and how to transform this into the relational model. So this is what we're focused on. And so my question was, we have two tables that capture the entities. That's the easy part. Taking entities and turning them into something that exists in the relational model is fairly straightforward. But I'm interested in how to capture the relationship of the ER diagram. Works in ID as foreign key in employees table. Employee ID as a foreign key in the department table. Third table as primary keys that reference the other two tables. Okay, I'll pick a couple of these sort of at random. First, I see I'll save this third table for last. I've seen put the primary key of DID in employee table. So, Lydia, you say that here I can add a DID here, and if you have a mic, can you unmute it, Lydia? Just because it'll make interacting a little bit easier.
Oh yeah. So I mean, I guess I didn't take into account that the employees can work in multiple departments, but if they could only work in one, like the DID could be used to reference the department table.
Right. Okay. Yes, that's true. But in this case, it's unconstrained. So that's the problem with this, because there would be no way to have an employee work in multiple tables, because you might have an employee here that you want to work in. Well, let's see. Actually, you could still have them work in multiple departments if you made this a composite key. And this could be a foreign key, for example. Is there something else wrong with this that you can see?
I guess it doesn't account for the relationship. If you want to look at the department table, like all of the employees working on in the department. I'm not too sure.
All the employees working in the department. Yeah. So this would kind of work. There is also this this since that should be captured somewhere. But this is an option. What else did I see? Thank you, Lydia. Or was it Lydia? Yes. Okay, let's see. Works in ID as foreign key in employees table. Works in ID. Alina, can you tell me what you mean by that? Works in ID as a foreign key in employees table.
Yeah. So that there would have to be a third table, as I mentioned before. I don't know.
Oh, okay.
And
Oh,
in the
I didn't
third,
see that. Okay.
yeah, primary key works in ID.
Okay, so I'll make a third table, works in. And which attributes should this table have?
Just well, the first thing would be the works in ID, and then
What is works in ID?
it's like it's like this primary key that points to, like, I guess it would have to be a composite key of, like, I'm not sure, a composite key with like the employee and the department. No, okay. Scratch works in ID. I just got it. So it's basically, it works in as a table, and it has just two attributes: employee and department. And yeah, and a third one, works in ID. Sorry. Yeah. So like works in ID, employee, and department. employee ID and department ID. And works in ID is the primary key, and then the I'm not sure what it would be called, but employee ID and department ID would be some sort of composite key that connects employee to department, kind of. And yeah, works in ID would be a foreign key in the employee table.
This would be a foreign key pointing to which attribute?
So there would be an attribute in employee, fourth attribute. If you were to add another column, it'd be a fourth attribute works in ID.
Okay.
And then, so for example, if the employee works in multiple departments, works in I'm not 100% sure how this would work. Actually, I don't think works in ID is necessary, but I'm just trying to connect them somehow. Basically, works in ID would be like, for example, employee one, it could be employee one, department one, employee one, department two, employee one, department three, and that would just be each like separate rows.
Okay, let me ask you a quick question. For the employee ID, if I have this works in ID here, is that well, so is this a primary key for the employee table, or is it a key at all? Is it a unique key? Is it just some
It's not
attribute?
a primary key. I'm not sure if it's necessary. I'm not sure if it's necessary. I think that if you just took out works in ID completely, you could just use
From
employee ID and department ID in the works in table
okay,
to connect them. And then each time there's a new department for a single employee, you just make another row. Yeah.
okay. So this is closer. Yeah. So we should not add another works in ID. Thank you very much. Yeah. It doesn't help anything to add another unique ID to the works in table. You can do it, it just won't help anything. Okay, what else am I seeing? Lydia says a third table with SSN DID as primary keys that reference the two other tables. Okay. Lydia, can you unmute yourself?
Yeah, so I guess this kind of like solved the problem where I was restricting an employee in a department. So we could have many employees that work in many departments, or many departments, or a department that has many employees. And then you could put the since attribute in that new table. So kind of like what we saw in the other example.
So sorry, should I add a fourth table or add another column to one of these three tables, or
Yeah, so in works in, you could have since.
okay,
That would be an attribute.
okay.
But then it would have a concatenated primary key with employee and department.
So with I don't know, I guess sort of a concatenated key like this, everything is concatenated together.
Yeah, I guess so, since in the diagram, since is underlined.
Okay, and is there anything else about these keys, or is this are we finished?
Well, I guess the employee one should be the social security number, just so we can link it back to the employee table.
You're saying make the employee attribute in the works in table a foreign key?
Yeah, for employee. Yeah.
For employee, okay. Is that the only foreign key?
So the department two would be the DID for department.
Yeah. Okay, excellent. Thank you very much. Yes, so this is the way to do it. In this way, you can create a third table. So for the employee entity, this becomes its own table. The department entity becomes its own table. And then this relationship is also a table. And because this relationship here is connecting this entity with a primary key, employee, and another entity, departments, with another foreign ID, with another primary key, then in the works in table, the primary keys should both be columns in this table. And then in addition, because there's this attribute here, since, then I'm adding that as a table as well, or as a column to the works in table. The employee attribute in the works in table points to, as a foreign key that points to the social security number in the employee relation. The department ID in the works in table is a foreign key that points to the department ID table. And because since is also a primary key for the works in relationship, then all of them get concatenated together. So in this way, for example, I could have an employee here that has worked in, I can have him work in more than one department. Similarly, I can have one department having more than one employee. And nothing is violated because it's the triplet together. It's this, the whole thing is this whole thing is a concatenated key. Okay. It wouldn't be concatenated with since. Hold on, there's some things. I don't think works in ID is necessary because a composite key of employee and department serves the same purpose. So it depends, Brian. You don't think works in, oh yeah, works in ID isn't necessary. Yeah, you don't need to add a separate ID, but you do need a since. And this captures this difference. There is a difference if I, for example, didn't make this a primary key. Right now, viewing these as sets, you can have one employee here. You can have one employee working in one department. You can have one employee working in many departments, no problem. But the problem is, what happens if you want to have one employee work for the same department over 2 different time periods? So maybe this employee worked for this department at some point in the past, started working for another department, quit or whatever, and then started working for the same department again. So it depends on if you want to capture this type of relationship, which is you can capture if you make since a part of the primary key for works in. So all 3 become primary keys. There is only one primary key here. It is a concatenation. So let me put this down here, I guess. I'll call this works in. And I'll keep things written this way. You could actually, if I named this SID and this DID, it would save a little bit of typing, but just because employee department is a string, sure. The department here is char 11. So I'll make this the same length. And since will be a date. And here, the primary key is going to be department, or I'm sorry, employee department since. So one key, one primary key, but this primary key is a concatenation of all three of these together. Is there a limit to how many primary keys you can have? Yes, you can have exactly one primary key. How does a three-way primary key work? Elena, can you unmute and ask that in more detail?
I mean, yeah, like Karina Liu also had the same question. So, and she asked, like, is there a limit to how many primary keys you can have? Like, what does it mean to have a primary key with so many different attributes? And what's the difference between that and having
What does it mean to say that again? I'm sorry, I just missed it.
I don't understand like, how you can have so many attributes connected via primary key. What's that and just having primary keys at all?
What's the point of having primary keys at all?
I mean I understand that, but like how does like a three-way thing, like why is there, I don't really understand how there could be like so many connected to each other.
Why do I have all three here? All three of these keys together inside of the primary key, or all three of these attributes inside of the primary key. That's your question?
Yeah, and also like how does it actually work? How does it function?
How does it work and how does it function? That's a good question. If it slips my answer or if I forget about it, ask it again. Okay, I will go back to this previous example that we had the last class. Here, students can only take one course and receive one grade for that course. Furthermore, no two students in a course receive the same grade. For this, we were looking at, see if I can copy the actual relation itself. Do I have it somewhere? Oh. Here. Wait, okay. So if I'm looking at this relation here, no, actually I don't need to do that. I already have it here. Okay, so first of all, you can have exactly one primary key. That's it. If you want to have more keys in addition to that, then those are called unique keys. For most things, the primary key and the unique key function in identical ways. One difference is that a unique key, can have null values. Primary keys cannot. Okay, so that's one difference. A primary key needs to have a non-null value. Unique keys can have null values. The other difference is when we talked about indexing before, and we talked about B+ trees or hash tables, the index is by default built around the primary key. So in this case, I'll look at this table here. if you were to create this table in something like SQL, then you could specify maybe a hash table, because student IDs don't really have, like, I'm not doing range queries on them. So maybe I'll make that into a hash table. So the index would be built around the primary key, and the data on the disk would also be optimized around this primary key. And the way that the index is built for the primary key is somewhat different than for the unique key. This is using something I didn't quite get into called a clustered index versus a non-clustered index. The primary key uses a clustered index by default. The unique uses a non-clustered key by default, or a non-clustered index by default. Because I didn't teach them, I won't say anything more about it than that. And that's just the default value. You can change the default value to make the unique key work even more like a primary key. So that's what I want to say about the sort of structural difference between a primary key and a unique key. Now, to answer your first question about concatenating keys together, here are two relations, each of which are referencing three attributes: the student ID, the class ID, and the grade. Here's the student ID, the class ID, and the grade. Now, in this relation, the class ID and the grade are being concatenated together, where here they are not. So the difference here would be, let's take a student 1111, and so here's SID, CID, and grade. It's an A. Now, this now, I'm referencing this table because each of these are individually keys. There's three keys for this relation. SID is a key, CID is a key, grade is a key. And for all intents and purposes, there's no real difference between which one you pick as a primary key and which you make a unique key. There are some differences, but nothing significant for the purposes of this explanation. Now, with each of these being individually keys, for example, I cannot have this. This is not allowed because it violates this key constraint. It violates the SID key constraint. Okay, that's fine because students can only take one course. So, so far, so good. Let's see about if I had a different student now. And they are taking also the same class 1. And they're going to receive an A. No, a C. In this way, when each of these three are individual keys, this is not allowed because it's violating this key constraint, the CID key constraint. But this table here, if instead you make these a concatenated key, then these two relations are okay, because 1A is different. Sorry about that. Oh boy. 1A is different than 1C. Does that make sense? So this is the difference between a concatenated key and keys which you're defining sort of individually, like this. Yeah, here's a concrete example. So these two relations, the first and the third row, would be not allowed in using this definition when you have 3 keys. But when you have 2 keys and you're concatenating these together, then we try to use the same colors. When these are concatenated together, then these entries are allowed. Under the original, okay. So first of all, does that answer your question?
My question, or
Yes.
kind of like I asked a different question as a follow-up of it, but like, is there a limit to how many primary keys you can have concatenated? Or would it be prudent then to just make a separate single primary key?
You can have only one primary key. Is your question, is there a limit to how many attributes you concatenate for that primary key?
So like if you had SID, CID, and grade, or in the previous example that we were working on, if you had SID, DID, and since all concatenated as one unique ID, which I think that's what we decided was the
Yes.
correct answer.
Mhm.
So like, is there a limit to how many you can have concatenated in a primary key, or would it be better to then just create a separate, like if you had like 7 attributes that you wanted concatenated, like if you wanted works in since, and then you also wanted like a lot of other attributes, would it be prudent then to like have a separate, like have that all be attributes and then create a separate primary key like works in ID?
I guess I'm not exactly sure how to answer your question. There is no limit to the number of attributes that you can use to create a concatenated key. The limit is the number of attributes. So here, the works in table has 3 attributes, so I can only have, at most, I can concatenate 3 attributes. I can't concatenate a 4th one. For example, if I wanted to add here dname from the department table, if for whatever reason I wanted to use that, this would not work because dname isn't a part of the works in table. So I'd have to create another attribute here called dname.
And that attribute dname, so what if like department name doesn't really change depending on the department? So you could, is that like an attribute? Like, could you, if you had it as an attribute, just list it after the primary key as a regular attribute?
Yeah, I'm sorry. Can you repeat the question? You're talking about in the works in table, not in the department table, right?
Yeah, like if for some reason you wanted department name dname in your works in table,
Mm-hmm.
that would be outside of your primary key, right?
I could add another attribute here, dname, and it could not be a part of this key. That would be okay. For example.
Okay, yeah, I guess that. Yeah, you basically answered my questions, so thanks.
Okay, sure. Okay, great. Then now I want to make a small change. I will take this same example here. Paste it here. Really? Okay. Now I'm going to just add a small change here. So now I'm saying that a department must have one employee. How do things change? Let me see if I can copy these. And people can type their answers or if they have any thoughts about stuff while I'm doing this. Get rid of that. Every employee has at most one department? No. This constraint is on the departments. So the employees are still unconstrained. You can have an employee work in no departments. You can have an employee work in many departments. Here, this is saying that I'm sorry, a department has at most, at most one employee. Sorry, not at least one, at most one employee, a department does. So, how should I change things here? And we'll end on this example. Department can be unique in the works in table. Department as foreign key in employee table. Remove the third table. Okay, so first for Alina, if I have the department ID in this table, then this would limit an employee to being only able to work in one department. But that's I don't want to. There is no restrictions on employee, so I don't want to add any columns to the employee table.
Yeah, I think other way around. Employee ID in department table.
Employee ID in department table. Yes, that would work. Okay, so this is hold on. So then, do I have a third table then?
Nope.
And what kind of key, or is SSN a key? If so, what? Yeah, in the department table. So you're saying I don't need this table, the works in table. So you're saying get rid of this?
Yeah, I forgot about since. So yeah, you should. It would probably be a composite key, SSN, and since, like Towin said.
Both of these just a composite key, or is this a composite key with the DID?
Yes. I think it could probably be a triple composite key with DID.
Okay. If I make it a triple key like this, then for example, here I'll have a department. I'll have 1, 1, 1, 1, 1, 2, 20, and here I'll have 1, 1, 1, 2, 2, 2, 2, 1, 2, 20. This would be allowed if this is a composite key, because the triplet doesn't appear more than once. But this is saying that a department can have at most one employee. So this should not be a triple key here. You can't, DID should itself be a primary key, or it should be its own key. Oh, and SSN is a foreign key. Flip the arrow from department to works in table do not have employees as part of the composite key. Okay, so I'll go off of this example next time. So this is one way of doing it. In fact, this is oftentimes a preferred way of doing it. Just extending the department table with attributes. That works in this case. And because the DID here is its own key, then you will not have entries like this allowed, because this conflicts with this key, which is what we want here. This is what we're going for. So that works. As a second option, let me just put that off screen. You could have the works in table as well, except here you would only have the department as a key. So this would point to employee. Since is fine. Employee here is now not a key, but the department is a key. So now this would not be allowed because it violates the department being a key. Oh, and department is also still a foreign key. So you have two choices. You can keep works in as its own independent table, but you change the key to only be the department. The employee is now no longer a key. Otherwise, as a second option, you can have you can nix the works in table altogether and just have the department key point with social security number as a foreign key into the employee relation. So two options of what to do. All right, I will leave it there. I don't want to keep you guys past class, so thank you. I will take this and upload it to YouTube, and I'll share the link with everybody. Okay, have a good weekend.